Hello, my name is Daniel,
I'm Luke.
and today we're talking about the law of cooling.
Newton's law of cooling.
Newton's law of cooling. So, I think first things first, we should write the equation down, don't you think?
I think the equation is very
Yes.
crucial to solving these types of problems.
Can't do it without the equation. So, first order of business, T of T, which is the temperature at time T. There's going to be a lot of T's, so stay with me now. It equals T of S plus.
Plus.
So T of S, this is the ambient temperature, like of the ambient surrounding. And then plus, that's a plus, not a T. Plus the, in parentheses, T
Initial.
0, which is
Our
T
initial,
naught, which
yeah.
is the initial temperature, minus that ambient temperature, which, if you remember, it's also over here, fun fact, times E, which is E, right, 2.71 something, to the power of negative
KT.
KT. So why don't you explain what K and T are?
So K is going to be the
cooling constant.
Yes.
It's different for everything, so sometimes we have to find for it, sometimes it's given to us.
And then these T's are all going to be at the time of which you are going to solve.
Yes, so lowercase t is time.
Time.
And temperature,
T
temperature,
is the big T.
Oh boy, am I late for math? Come on, dude. Wait a minute. What is that? What the heck, man?
One day later.
This will show him.
Man, do I love parking wherever I want, especially in front of people's driveways. It's like they don't even care when I park in front of them. Oh, this is a good spot. Oh, what a nice day it is today. Uh-oh.
Oh man, have I been waiting for this?
Hey, I promise I didn't know, man. I'm sorry. I promise I didn't know.
Eventually.
Another day, another case. Let's see what we have here today. Okay. Ambient temperature, 70 degrees Fahrenheit. Let's check his pulse. Seems like the body's about 85 degrees Fahrenheit.
Later.
Check again. Huh. Seems like his body's now 80 degrees Fahrenheit. It's been 30 minutes. Interesting.
Okay, so as we saw in the video, the ambient temperature of the surroundings in that room was 70 degrees. Pretty cold day. And the initial temperature of the deceased person is, we were saying it's normal body temperature, which is 98.6 degrees Fahrenheit, which we just know that to be the normal body temperature, or you can go on Google and search that up. And then, so when the body was first discovered, the temperature reading was done, and we saw that to be 85 degrees Fahrenheit. Now, after waiting 30 minutes from that initial discovery, the temperature of the body dropped to 80 degrees Fahrenheit, which means that after 30 minutes, the temperature went down 5 degrees. And take it away, sir.
All right, so now knowing all this information, we can plug all of these variables into this equation. So we can first start off with T of T. So we want to see that after 30 minutes. So we can have our T is equal to 30 here. So T is equal to 30. So we just know that in general. So now our T of 30 is equal to 80. So we can set 80 on this left for this like T of 30. And then our ambient temperature is going to be 70 degrees. So we can just plug in 70 right here. And then it's basically just plugging in all the variables. So our initial temperature was 98.6, and then we just minus that by the ambient temperature again, which is going to be 70. And we multiply all of this by e to the negative kt. And the point of this equation, with all these variables here, is we are finding the k constant. So now we can plug in, we can use the e to the negative k, and we know our t right here is 30. So we have negative k times 30.
Okay, so now let's crunch some numbers and
Yeah,
see
let's
what
crunch these
that
numbers.
comes out
So,
to. So,
we want to take away with the calculator.
Yes, so
we have
just-
80 is equal to 70 plus 98.6 minus 70 is going to be
wait, how do you-
28.6. And then
Yes.
all this is equal to e to the negative k times 30.
Okay.
So now we want to just keep just the e to the negative k 30 because we're trying to just isolate this k variable.
So subtract,
So we
subtract.
subtracts the 70 on this side, divide this 28.6. So we can do that right now. This is going to be 10 divided by, so we just minus 70, which is 10.
Which is,
Now we can divide it by 28.6.
which we can just keep in this form because we're going to be working
Yeah.
with that number later on. So,
Is equal to e to the negative k times 30. Awesome.
now to get the t or the k just by itself, what we want to do is take the natural log of both sides because natural log is just log base e, and then this e with natural log, it'll like crisscross applesauce cancel that.
Alright, so
So-
now you have the natural log of 10 over 28.6,
Right, a little bigger.
which is equal to negative k times 30. Awesome.
Okay. So now all that's left to do, divide by 30, divide by -1, or multiply by -1, I mean, and then we can get just k alone.
So we can easily do that. So it's just natural log 10 over 28.6 all over 30. And then our k comes out to be, drum roll please,
Drum roll, please. Times -1 equals 0.035 03.
Awesome. So
Wow.
now we have our k value.
You're not in the video.
Now we have
Pat
our
on
k
the
value.
back.
Yep.
Pat on the back. Okay, so now that we've solved for k, we can actually find when the deceased person was killed. So, T of t, which if you remember from earlier, is the temperature at time t. So we don't know when they were killed, right? But we do know that when the detectives found the body, the temperature of the body was 85 degrees Fahrenheit. So, using this information and that information that we found previously, we can just plug everything into the equation up here, and all that we would have to solve for
Just be t.
is the t over here.
Yep.
If the video even shows it, I don't think it shows, but okay, anyways. Put an 85 here. Temperature of the ambient surrounding, we said, was 70 degrees. Plus the initial body temperature, which we're assuming is normal body temperature,
98.6
98.6, thank you.
degrees Fahrenheit. And then
Minus that ambient, minus the ambient temperature,
which was 70 degrees Fahrenheit.
70, and then times
E
E minus,
to the negative 0.03503 times t.
times T.
So just like earlier, now we can do the simple.
Crunch some numbers.
Yep.
So let's get rid of this K over here so I have some space to write. So, so we put 15 here.
Because 70 minus 85 to make this
I got this part, bro, thank you.
is 15.
So then this would be 28.6. So that's just from doing this minus this, and then the 15 is from doing the 85 minus 70. And then times E to the negative 0.03503T. Let's write that 5 a little better. So now we divide both sides by this 28.6. So then we get 15 over 28.6 equals e to the power of negative 0.03503. How do we get that t down? Like I said earlier, natural log both sides, e's cancel out, it all comes down. So then natural log of 15 over 28.6 equals negative 0.03503 t. So then divide both sides by this k value, and then we find t, and then this negative would just go away. We don't care about a negative time, that doesn't tell us anything. So what would that number be?
So this t value would now equal 18.
So t
It's equal to 18.423.
4, 2, 3. So the detectives, us two, estimate that the deceased person was killed approximately 18.423 minutes after the police showed up.
Yep.